I'm delighted to present our recent work entitled Non-Placebo Controls to Determine the Magnitude of Ergogenic Interventions, a Systematic Review and Meta-Analysis. This study was performed by members of our Applied Physiology and Nutrition Research Group of the University of Sao Paulo, led by Felipe Marchicorena and accepted for publication in Medicine and Science in Sports and Exercise. Placebos are inert substances or interventions historically used as a comparator to identify the effectiveness of an intervention, such as a medicine or a supplement. However, we know that the placebo effect is a measurable phenomenon that can generate a positive outcome despite having received an inert intervention, which could modify study results. Placebo effects in sport and exercise are also apparent. A systematic review showed that individuals receiving an inert treatment, believed to be something beneficial, thus providing positive expectation, could generate small to moderate improvements in sports performance. This raises the question, how much of the positive effect of supplements comes from placebo effects? Most studies investigating the effects of supplements make comparisons only to a placebo control. In the real world, the actual effects of supplements are likely to comprise both their active physiological component and associated placebo effects. This means that studies could underestimate the overall real-world impact of a given intervention if they do not include a non-placebo control arm. The main objective of this study was to estimate the size of the placebo effect associated with ergogenic interventions in sport and to determine factors that could modify this effect. To undertake this study, we chose to investigate two supplements, caffeine and extracellular buffers, such as sodium bicarbonate, since they are considered effective ergogenic aids, while both have been shown to induce placebo effects. To identify relevant articles, 3 databases were searched using relevant search terms. Note that only supplementation studies with both a placebo comparator, in which an inert substance was provided, and a control comparator, in which no treatment or intervention was received prior to exercise, were included. Following our study selection, a total of 34 articles were included, 10 with caffeine and 24 with buffering agents. The first analysis, comparing the placebo control versus the non-placebo control, showed a very small but significant placebo effect on exercise performance, demonstrating that the administration of a placebo in double-blind studies has a positive effect on performance. Moderator analysis showed that this placebo effect was greater when supplements were provided in solution compared to in capsule form. Finally, when evaluating the proportion of the total supplement effect attributed to placebo, we found that a large proportion of the overall effect, approximately 59% for caffeine and 25% for buffering agents, came from placebo effects. This can be extremely important information, both for scientists and practitioners. Where feasible, researchers should aim to employ a non-placebo control arm as a comparator to measure the overall effect of the intervention, both physiological and psychobiological, and identify the proportion of this effect that can be estimated to come from placebo effects. Coaches and practitioners should be aware that actual ergogenic effects with these supplements are likely greater than those shown in placebo-controlled studies, because in the real world, the net effect of the physiological effects of active interventions and their placebo effects are additive. Practitioners should also consider taking advantage of these placebo effects inherent to effective interventions by instilling positive belief in them to optimize training adaptations and performance outcomes.